Michaela. Thanks for sending another question. So I neglected to input the 4 when I sent you the answer to the last problem. The derivative that we had obtained at the end was negative 3 times x minus 4 over the absolute value of x minus 4. So inputting 4 here, it's not hard to see that you're going to end up with a 0 in the numerator and a 0 in the denominator. Your derivative at x equals 4 is actually indeterminate. I believe you could write undefined, and your professor would probably accept that. Actually, if you look at the graph of this, it's going to look like a step function. There's going to be horizontal lines, and then you're going to have a big vertical line at x equals 4. So let's go ahead and move on to your next problem. I believe you had come up with this solution here. No, it is not correct for 2 reasons. One, you neglected to put an argument in your secant function, and the argument for your tangent function is incorrect, but everything else is correct. So let's see what's going on here. So the first thing I'm going to do is rewrite the way this term is written. Whenever you have these trigonometric functions to an exponent, go ahead and pull that exponent to the outside. What we really have here is secant of 7x cubed, and you'll notice that I've encapsulated each of my functions in parentheses. That is really going to help us keep things clear when we apply the chain rule and help us avoid very common mistakes. So let's go ahead and count how many functions we have so we know how many times we need to differentiate when we apply the chain rule. We have a cube function as our outside function. That would be 1. The secant function is our middle function. That would be 2. And then in the argument, we have another function, 7x. That would be 3. So we're going to be differentiating 3 times. Let's go ahead and start. We're going to start from the outside and work our way in. So let's go ahead and bring down the 3. And then we're going to take everything that this cubic function encapsulates, and we're going to rewrite it. So secant 7x, and then we're going to drop down this exponent by a value of 1 so that it becomes a square. Let me actually put some outside brackets around this. So that's our first differentiation. Now let's do our middle function here. Secant, well, the derivative of secant is secant x tangent x, but we don't have an x. We have a 7x. So we want to make sure and note that. So secant, everything that's inside the secant function. Tangent, everything that's inside the secant function, that's 7x. And that is our second differentiation. Now let's go ahead and move on to our third. Our inside function is 7x. That's a nice easy derivative. It's just 7. Let's go ahead and simplify. 7 times 3, we can certainly pull that to the outside, 21. It looks like we have secant of 7x squared and another secant of 7x here that we are multiplying by. So that's going to become secant cubed 7x, and we have a tangent of 7x. And this should be your final answer. Thanks again for your question, Michaela, and I look forward to answering more of your questions using SnapMath in the future.